Hello everyone, welcome to this tutorial. I'm Safat Smail, an IGCSE and A-level math teacher. And in this tutorial, I'm solving a recent exam of Pure 2 Edexcel of this month, October 2024. And the first question we have in this paper is about trapezium rule. So here we have a table of values of x and y for a continuous curve y equals f of x. And the question is asking to use the trapezium rule to find an estimate of the definite integral from 0.5 to 5.5 of the curve. So as a start, I'm going to make a sketch of the problem here. So we have a curve that is f of x. We need to find the definite integral from 0.5 to 5.5. And the definite integral here means we need to find the area between the curve and the x-axis. And to estimate the area, we need to divide the area into trapeziums. Because if we just use only one trapezium, like this, it would give us an underestimation of the area. Because as you can see, this part is not counted. So the area of the trapezium would be an underestimation of the area or the definite integral. So to overcome this problem, we need to divide the area into trapeziums. Here is the first trapezium from 0.5 to the second value, which is 1.75. The second trapezium is from 1.75 to 3, and then from 3 to 4.25. And the last trapezium is from 4.25 to 5.5. So in total, we have 4 trapeziums. So we have the number of strips is 4. Second step is to find the height of each trapezium. And the height of each trapezium, you can spot it directly from the difference between the x values, like 1.75 minus 0.5, which is 1.25. Or you can take the whole distance from the first x to the last x and divided that by n, which is 4. So we can use the rule b minus a divided by n. b is the last value for x. A is the first value for x. So it's like you find that the total distance from the first x to the last x. Then divided that by 4, which is the number of strips or the number of classes. So 5 divided by 4, which is 1.25. So we have the height of each trapezium. Now what's next? We name the y values. We're done with the x values. Now we move on to the y values. I'm going to name it as y0, y1, y2, y3, and finally y4. Now use the trapezium rule, which is given in the formula booklet. So area equals h over 2 y0 plus the last y, which is in this case y4, and then 2, and between brackets we include y1, y2, and y3. Now, why do we have y1, y2, y3 between brackets and it's multiplied by 2? Because each value of y from y1, y2, y3 is repeated twice. As you can see, this is y1. It's considered twice. One time with the first trapezium to the left, and one time with trapezium to the right. And that happens with y1, y2, and y3. And for y0, it's only repeated one time. For y4, it's only repeated. It's only mentioned one time. Now use the values we have. We have the height. We have y0. We have y4. We have the values of y1, y2, y3. So we can find the estimate directly, which is 1.25 divided by 2, y0, which is 3.479, y4, which is 5.182, and 2 times 6.101, 7.448, and 6.83823. Now use your calculator to get the final answer. The final answer is 61.756 0.25. And here it says round the answer to 1 decimal place. So this is approximately 61.8. So this is the answer for the definite integral, and it's the answer for the area between the curve and the x-axis from 0.5 to 5.5. Now, the second part, it says using your answer in part A and making your method clear, estimate the definite integral again of f of x plus 4x dx. And the thing is, we need to use the rules of the definite integral. And the rule I'm going to use in this part is when I have two functions, the definite integral of f of x plus g of x dx, this is the same as the definite integral of the first function plus the definite integral of the second function dx. So if we apply it here, I'm going to have the definite integral from 0.5 to 5.5 f of x dx, which we have the answer already from the first part, 61.8. And we have the definite integral again of the second function, which is f of x, 4x dx. Now, the first part is already 61.8. And all we have to do here is to integrate 4x and then use the boundaries 5.5 and 0.5. So to integrate 4x, we use the rule x to the power of n plus 1 divided by n plus 1. And we have the boundaries a to b. Then substitute b minus, and we substitute a. So if we integrate 4x, it will be 4x squared divided by 2. And we have the boundaries from 0.5 to 5.5. So 61.8 plus, now of course we can simplify. So it will be 2x squared. Now use the upper value, which is 5.5. So 2 5.5 squared minus 2 0.5 squared. And the answer for this part is 60. So 61.8 plus 60, that's going to be 121.8